Recently, Anker launched its second-generation GaN charger, which is called Nano II series. There are three sizes: 30 watts, 45 watts, and 65 watts, and have brand new design, smaller size. The top silver gray area is the mark of Nano II series, very recognizable. This 65 watts charger also launched PI's latest Power GaN chip, InnoSwitch 4CZ series. A strong allies. Firstly, let's compare the Apple 61 watts to this charger. To be honest, it seems like the products from two different eras. Let's take a caliper to measure its size. Lengths, widths, and thickness will be 36, 41, and 44 milliliter. The weight is 107 grams, so we can know the power density is about 0.98 watts per cubic centimeter, very close to 1, and the number is very impressive. Even it's the GaN charger and can be that small and adopts foldable pins, pretty nice. And then let's test the protocol of this charger. There are 4 fixed voltage gears, 5 watts, 9 watts, 15 watts, 20 watts, and 5 to 21 watts PPS, and can fast charge some mobile phones that have PPS protocol. After reviewing this charger, let's do our job, tear it down. This time, Mr. Hammer will have a lady, Mrs. Spudger. Use a spudger and sledgehammer to insert the gap little by little, then pry it to open. We can see there are lots of thermal glue inside, which is very troublesome for our teardown. In this case, we can use a screwdriver to remove the folding pins firstly. Seems like it doesn't work. So the only thing we can do is to clean up the thermal glue and pull it out with pliers. Take out the entire PCB module. Oh my god, there are still so many thermal glues. Just continue to clean up and tear it down. After cleaning up, we can finally see something. Okay, let's see what's inside. Firstly, look at the small board for input. There are 3 components on this side. The first one is a fuse, covered by a heat shrinkable protection tube. The middle is the safety X capacitor. The last one is the common mode choke. There are 2 SMD rectifier bridges on the back, which can reduce the thickness and spread the heat. Secondly, we can see its connection board, which is used to connect input and output boards. There are 4 electrolytic capacitors for high voltage filters. And then let's see the back side. Here is the Power Integration's latest Power GaN chip, InnoSwitch 4CZ master chip. It integrates a PWM controller, a synchronous rectifier controller, and a primary switch moist tube. The Power Integration's Clamp 0 chip is next to it, which integrates high voltage switch tube and controller. Let's take a look at its electrolytic capacitor for high voltage filter. We can see 4 capacitors totally. 2 of them are covered with an insulating tube for protection. Finally, let's look at the small board for output. The 2 solid capacitors here are also protected by insulating tube. A synchronized rectifier moist tube is on the back, comes from Alpha and Omega AON6220. A Schottky diode is attached next to it. The protocol chip comes from well-trained WT6636F. There is also an Alpha and Omega output VBus switch tube next to the USB-C port. Finally, let's take a look at the USB-C female. There is a black rubber ring on the outside of the USB-C female for protection. After removing it, we can see a separate layer of steel tube is added to the outside for reinforcement, which can effectively prevent shedding and provide longer service life. So for this Anker Nano II GaN charger, the most impressive thing is the internal thermal glue of the charger, which can effectively improve the stability and heat dissipation. This charger used power integrations INN4075C and CPZ1062M for the first time, which can be more efficient and reduce temperature. And that's the reason why it will be so small. So do you think the Anker Nano II GaN charger 65 watts is small enough or not? Okay, that's all for our teardown, and that's all components for this charger. If you like this video, don't forget to drop a like, leave any comments, and if you want to see more content, please subscribe to the Charger Lab and visit our website chargerlab.com. I'll catch you guys in the next time.